anything yet, so maybe that's the reason you're not hearing it. So can everybody hear me now?
Yes.
Yes. We'll get started. And before I start this webinar, I want to talk about a little bit about the company, Scholar IT Solutions. Scholar IT Solutions, we are an IT solutions provider, and we are based on the US. We have like a team of highly skilled people with technological and domain specific knowledge, and we are very robust at implementing all the technologies, and we serve the entirety of US. Yeah, you can follow us on Facebook, Instagram, and LinkedIn to know more about the company. And today we'll be seeing about the introduction to the Google Cloud Platform, organized by Scholar IT Solutions. The traditional way of working things is you have a computer, you connect to the internet, you access a service, and you have a lot of options on how do you consume the service or how you access the technology and everything. And in this case, you require a lot of hardware. For example, if you're playing a video which is of 4K quality, you need a machine with a good GPU. And if you are playing a game with high-end graphics or something, you need a lot of system specification. And even if you have a browser with 50 tabs open, you would need a computer with a powerful enough processor to process that and enough memory to hold all those information. So what is the cloud? So cloud takes away all these problems away, because all these problems which are being prevalent in the traditional model of computing are gone now. So what makes cloud a cloud? According to the definition of the US government, a cloud is like defined by certain characteristics. You can't hear? Mishra Trupati. Is everybody else able to hear?
Yeah, yes.
Okay, can somebody respond to that issue?
Network issue maybe.
Okay, so yes. Should I continue or can we wait till the result?
Kamal, we don't have any issues. Maybe it's ad hoc. If they have issues, let them connect from mobile.
Okay. Okay, let me continue with that. So what are the things that define a cloud? On-demand self-service. So as far as any kind of service is concerned, there's like a manual intervention always present. Like if you are buying something from Amazon, or if you're buying something of a service, you need to contact the company's sales department and buy something. And the cloud is not managed by humans. It's automated. So it's self-service. You just go and request the features and you get it. So that's what makes a cloud a cloud. So, and the thing about the cloud is you can access it from anywhere. It has a broad network access. It doesn't matter if you're in India or in America or if you're in Australia, it's equally accessible everywhere. So it's not specific to a region. And resource pooling. So provider shares the resources to the customers. So the resources are like each provider of the service has like a vast amount of resources depending on the size of the cloud, and which is entirely available to customers on demand. And whenever the demand increases, for example, you need more power, suddenly there is a spike in the user demand and you want more resources. Traditionally, what happens is when these kind of things are overloaded and the service is overloaded, we are like experiencing like the site is blocked, and like a lot of users cannot access the website, and a lot of people are denied service because then there is not enough server resources. So that's the problem with the server model. A server has a limited amount of capacity, like 200 concurrent connections or 500 concurrent connections, and anytime that kind of capacity is overloaded, it results in a lot of problems in a user trying to access that service. But that kind of problems do not exist in the cloud. It can be scaled to any level very, very easily, because anytime the need increases, the cloud automatically scales. You don't have to increase the power, it automatically scales. And the most attractive of all these things in terms of business people is measured service. You pay for what only you consume. A traditional model includes like subscription or any kind of resource allocation, and you have to pay. You have to pay regardless of you using the service or not, so that you get locked with a monthly deal, and any kind of resource, whether you use it or not, you end up paying for it. And that does not go well with the business people. But in the cloud, that does not happen. You only pay for the resources you use. Let's just say you don't have any kind of access service in a month, you won't be paying $1, because only the resources which are consumed are billed monthly. Okay, so let me talk about a little bit of how we access these cloud services. So in a traditional way, we access these services using websites or mobile phones or computers. And cloud can be accessed in the same way. Software development kit. So every time we need to access the cloud, we go through a set of channels, or like, how do you say it? A way to flow into the service, get the output you want, and then come back. SDKs is one of the SDK is one of the popular methods of doing that. It comes with bundled with every software, and Google Cloud Platform and all the other people who are providing these services bundle their SDKs, which can be put in almost everything. For example, you can be using the same SDK in some Visual Studio and Unity or any kind of platform which supports SDKs. Mobiles are the most popular ways of accessing cloud. In fact, the cloud was born because of mobiles. The vast majority of the users consume services these days using only mobile phones. And this is also the reason why the cloud concepts are taking up steam. Web is another way of accessing the cloud platforms, and it's a very popular method even with the advent of mobile phones, mainly because web is agnostic to platforms. The web is accessible to all platforms equally. And APIs also opens up the access to the platform to multiple people, regardless of their what the language they use, or because when you're using an API, you're just sending a request and you're getting an output. That does not have to do with if you're using C++ or Java or anything. So whatever language, whatever platform you come from, the API gives you access to the cloud. As far as Google Cloud Platform is concerned, there are 4 main services which are offered: compute, storage, big data, and machine learning. So let me talk about a little bit about each service which Google provides. So compute. So the main thing about compute is compute offers virtual machines, and it can range from platform as a service to infrastructure as a service. And later in the slides, I'll talk in detail about this alone. So let's talk about the other 3 which will not be covering in this seminar. Storage. Everybody knows about storage. So we need storage. Everybody has a problem in their mobile phones or their computers. The files and everything else have to be stored, and you have to deal with a lot of problems which come with storage as well. For example, power cuts or failures may damage the hard disk, or sometimes you might not have saved your files, and that any kind of power cuts or hardware failures or any kind of issues or software crashes, even software issues are more causing data loss than all the other things combined, because softwares tend to be unstable. So these kind of problems do not occur in the cloud, mainly because cloud storage is very reliable, and at any point of time, your data is stored in more than one location. So even if one location does not go well, the other one is there for backup. So every single file is almost stored in 2 different locations, which are independent from each other. So what are the types of storage which is available? So the main thing is simple storage of files or documents is available. And everybody might have known about these Google Docs, Google Sheets, and Excel sheets. These are document formats. The thing about document formats is that they don't occupy that much space. And they are very light, and mostly because they are composed only of text and simple images. But that is not the big thing about storing, right? In terms of access of a document, you can access the document from anywhere. That is the advantage of storing a document in the cloud. So when you're working on a document and suddenly you have to go to another place, which is far away from, maybe you're going to Singapore, and the next stop you're going is to US, and then you're coming to India. So you'll be able to access the same document wherever you go, because you're not storing it locally in a disk or in a local server where you don't have access to the international thing. And file storage as well. Anytime, like in terms of, like, for example, the entertainment industry, where the file sizes are phenomenal, like in terms of terabyte size of each videos or anything can be like a terabyte size, and you can't really transfer them around, hard transfer them around here. So these kind of storage options help the entertainment industry, like, manage all their storage options. So they're accessible to all these people. For example, like there's a person in US and he has like a TB of video data. And this person is actually has to outsource the videos in India. And in that case, like the best option should be doing like is the cloud, because you can't physically transport 1 TB of data through aeroplane or any kind of file service and expect it to go regularly. If the data, if it's like a small thing, like about 500 MB, 700 MB, 1 GB, 2 TB, 1 GB, 2 GB, it's not a problem. But when it's in TB sizes or something, you need something of a reliable mode of transport, which can handle errors and failures as well. And the topic of storage also goes to databases. And databases are stored in huge numbers. And these days, also, like, huge amount of data comes out from even the basic of apps. Data is everywhere, and business people are quite fond of data to know more about the users. And now the next thing comes into picture, big data. So the thing about storage is it's just storing the different kinds of documents, files, or data. Storage alone cannot be, like, in terms of business, people require analysis. They don't want just raw data. They want analytics. They want insights. They want data visualizations. They want like more of a business kind of content, which is information derived from data to make decisions based on the business they're doing. So that's where big data comes in. Google Cloud Platform and all the cloud platforms, they provide a huge amount of analytical services and big data services to actually analyze and give insights, and also provide very, very visually appealing data visualizations. And finally, we have the machine learning. Artificial intelligence. Artificial intelligence has become a part of our lives. Whether we know it or not, it's slowly creeping into everybody's life. When you're like watching something in YouTube, and then there's a video suggestion coming to you, and you don't know the amount of work that goes behind that video suggestion, the amount of data which is collected based on you to make that video suggestion. That is where machine learning comes from. Machine learning is where you collect a vast amount of data from a user's behavior, a user's habits, or the way they talk, or the kind of information they look for, and suggest them the appropriate videos or products or anything. And machine learning does not stop with that. Machine learning also is like, for example, what makes a dog a dog, what makes a cat a cat. That's what's the kind of data which is stored in machine learning platforms, and it helps organize these pictures. And the amount of pictures a person takes per day is huge. You can't manually manage all these things. For example, Instagram, per second, there's like about millions of images uploaded to Instagram. And let's just say there are offensive images or vulgar images being uploaded. There is no way for us to manually find out each image if it's offensive or vulgar or anything. So what we do is machine learning. We automatically build machine learning models. And using those models, we can find out if this image is offensive or vulgar, and automatically screen it and remove it from the system without any kind of manual intervention or people or staff required to that. And for that to work, we have to build machine learning models and train them appropriately. And finally, we can actually do a lot of manual work without actually any manual intervention at all. And since we are hosting all these things in the cloud, it means that you can access these services from anywhere around the world. Okay, so let me talk a little bit more about the GCP architecture. So architecture depends on what kind of product you want. Any computer architecture is like, for example, desktops. Desktops are built to architecture for application programs for users. And depending on the user, a power user might use like more RAM and computer with higher cores and processing. A normal user who's just browsing the internet might use some low-end systems. And it depends. And this architecture cannot be changed because when you buy a computer or when you buy physical hardware, you're stuck with that. And there is an option to upgrade, but you can only go so much with upgrades. So the main two things about architecture in Google Cloud Platform is like compute engine and managed services. Everything in between is a little bit of hybrid of both. Infrastructure as a service on the left to platform as a service on the right. So what's infrastructure as a service? Infrastructure as a service simply means that any cloud provider just provides the infrastructure. They don't provide anything else. There is no platform or there is no like any kind of thing. In this case, the people who come here, they can host anything on that. They can bring in their own platforms. They can bring in their own virtual machines and their own OS. Some people actually have their own operating systems even. So in that case, you can go for infrastructure as a service. Platform as a service or the app engine is where you can actually run an app where there you have a pre-configured platforms depending on the kind of app you want to run. And Google Platform Zones and Regions. So like I said about the whole cloud covering the entire world, there are different zones and regions. So the region, US is a region, Europe is a region, Europe West 2 is a region. So every major region or major continents are divided into regions. And the regions are subdivided into zones. So what's a region and what's a zone? Like what makes a difference? And the thing about these zones is anytime you store something in this zone, people in that zone or everybody have like a very low amount of latency when they're accessing the services. For example, let's just say you have a company, which is a banking service company, and the majority of the people in your banking service company are in the Europe area. So it would make logical sense to host it in the Europe region. And furthermore, zones are available for another thing. Each zone is available in a different data center. And the difference between the distance between the two zones is about 150 to 160 kilometers. And like I said before, all the data you store is stored in at least two locations minimum 2 locations. If you want more data security or anything like that, you can even store the data copied in 4 locations. And why do we have to store in 4 locations? Because the worst things might happen. For example, let's just say the Europe zone is stuck by some kind of widespread activity which disables like the entire thing. Well, that cannot happen, but the individual zones that can happen. For example, there's like a huge which disrupts all communication lines at all. In that case, the cyclone or anything like that cannot affect more than 300 kilometers. So if you store your data like about in a zone or a data center, which is about 150 to 300 kilometers distance away from each other, then you're protecting the data from one location. Only the other location gets destroyed or disrupted. And currently there's a lot of zones around the regions, and Google Cloud Platform is rapidly growing as we speak. And the company is aggressively expanding these days. So there might be new zones which are added, which were created after this image. And how do we choose a zone or region? Simple logic is that wherever your customers are based, and sometimes you might ask a question like how, what if I have customers all over the world, like I'm something like Amazon or financial services, which are available to almost every person in the world. In that case, you can choose multiple zones and regions, and you can screen them based on the customer base. So your service will be like the same, but each zone can be like differentiated based on the regional platforms or the regional kind of locations. And this is set to extend in the future. There will be more and more data centers hosted all over the world. So now let's go to the point where we compare Azure, GCP, and AWS. So in terms of each of these cloud providers, AWS is the biggest. It's actually much, much bigger than compared to Google, Azure and GCP combined, at least 10 times bigger than both of them. And AWS has been there for the longest. That means that they have more experience and more services. But does that make GCP and Azure relevant? No, because each person has its own advantage, and that's the same thing here. And how do you choose between Azure, GCP, and AWS? That again depends on the kind of services you're using, the kind of services you want, and also most importantly, pricing. So the first point is pricing. Azure is known for being very expensive. And as per Microsoft, they have a lot of user interface and they have like an easy way for developers to get started. And that comes at a price. Azure is clearly the most priciest among all the three platforms. And point to note is that Azure is also bigger than GCP, and it's the second biggest cloud in the world. And GCP is like the best option in terms of most pricing here. Since relatively new and aggressive, they are like trying to score a lot on pricing. If you want the lowest pricing with the most services, then GCP would be a natural choice. So, but that would be a different case in terms of features, because in terms of features, AWS has the most features. And Azure comes in a second, and GCP has the least amount of features. But that does not mean that you cannot easily make a choice even here, because it ultimately it depends on the kind of features you want for your application. For example, if you are a mobile developer who is going for Android, and that would make GCP like a viable, an obvious choice, because Android is developed by Google, so they naturally have like GCP services catered towards Android. And let's just say you're going for some other development like .NET, then Azure would be a natural choice, because .NET platform is owned by Microsoft, and they clearly have a huge advantage in programming and tight integration between them. But in terms of raw features and power, AWS is the biggest and a clear winner there. And the third thing, developer community. So why do we need something with a developer community? Because that is important. Any developer knows that they have a lot of issues implementing everything. Not implement like 1,000 questions you want to ask, and you want those questions. So this is where we have a clear loser, Azure. Azure has a low amount compared to GCP and AWS to ask any kind of questions once you're stuck. Any developer or programmer or any kind of architect, when they're stuck in something, they need somebody who's faced that problem before. Communities, forums, or any kind of way of interacting with people to get those problems solved. In that case, GCP scores well, because GCP has a community following and they're growing, although they are much smaller compared to the AWS community. And here we have a clear winner on AWS as well. The community itself is huge. Since it's the go-to for like large-scale operations and global operations, the developer community is vast in AWS. And it's good in GCP, but it's very bad in Azure. If you want to ask questions, you will have very low chances of getting answers. And the most thing, it would take like a 1 week or 2 week, and the reply would be from Microsoft itself. And documentation. AWS has one of the best documentation in all of these three platforms. They have a lot of experience in implementation compared to all the other platforms, and the documentation is mostly very good. And that goes for GCP as well. They have both community documentation and their own documentation, which is very, very informative. And they also have a knowledge base with a lot of definitions, even for the products which are not related to them. So that makes it an easy read for anybody trying to do this. And they also have a lot of step-by-step ways of configuring each and every application. And again, Azure scores very badly in this thing. Documentation is very, very poor, and they basically have only getting started videos. And apart from that, you have to mess with the API and find it out yourself. you will have very low amount of documentation to get started with. And training, of course, if you're going for a cloud platform, if you want to become an architect or an engineer or a warehouse engineer, you definitely need training and certification to prove your skills. And almost all three of them have very good training and certification. So that each in this kind of thing, like training, it is almost available in all three people, and you have to choose based on what kind of solution you're looking for, or what kind of company you're working for, or what kind of solution that the company is looking for. Adoption by companies. And here again, AWS is adopted by a huge number of people. Being the first person to come into the cloud market, they have scored a lot of people, from Netflix to all the big people have all adopted the AWS, because simply they have like a huge cloud distributed all over the world. So any kind of person targeting a global audience, AWS is a clear choice. And Azure is like a leader in the business space, where the .NET is like a de facto standard for anybody who's coming in the Windows market. So in that place, Azure is a clear leader. And GCP is relatively low in terms of adoption by companies, because it's kind of young. Like about 78 years before is when GCP came into being. And that makes sense, because you can't say GCP is bad because a lot of people not adopted it. It's because only it was announced in 2013 or 2012 roughly. So it's been only 8 years compared to like 15 or 16 years compared like for AWS, and 12 or 13 years compared to Azure. So in this seminar, I'm going to discuss in detail about only the compute options in GCP. Each of these options are very much detailed. So we have time only for compute options today. So I'll be discussing this in very much detail. So compute options, what is compute? Compute, the basic thing is virtual machines, infrastructure as a service. It lets you run a virtual machine where you can run your own programs, regardless, like depending on your needs. So what is a virtual machine? A virtual machine is, let's just say you have a Windows operating system and you have a Linux application. So what you do is you run a virtual machine where you install a Linux operating system on top of Windows. So Windows is running, and on top of that, a virtual machine is running. And on top of that, Linux is running. And on top of that, you can run your application. So why do we have to go through this on top of that to run an application? Because that's how the case is. Everybody has their own application, which comes from a different platform. For example, you might be still using this Windows XP application, which you've been using for 20 years, but now you have a Windows 10 system. So what do? You run a virtual machine with Windows XP, because you can't let go of the amount of data. For example, 20 years ago, you purchased a business application and you're not able to run it on Windows 10 because Windows 10 has improved a lot compared to Windows XP or Windows 2000. So what you do is you run a virtual machine, and you can't update the business application because it has a vast amount of data for your business, and you can't let that go. So virtual machines come in to fix this problem, and that would be a general use case. So who uses Google Compute? Google search engine, YouTube, Gmail, all the Google products. And the most important point to note here is Google search engine. And anybody who uses Google search engine with a good internet connection knows that it's pretty much the fastest. You can try Google, Bing, and other kind of services, and you would clearly know that Google is the fastest. So when you're running Google Compute, anything on Google Compute, you're running your programs on the same infrastructure, which runs the Google search engine, YouTube, Gmail, and almost every single Google service is run on a Google Compute option. So what it essentially does is it allows you to create virtual machines. So they have like a large amount of server resources, from CPUs to memory and like GPUs, everything. So depending on your need, let's just say you want a Linux application. You launch a Linux virtual machine. And the next thing you want is a Windows application. Your company might be crazy enough to do that as well. Like choose 2 different OSs and actually have them work with each other. And traditionally, that would be a problem. You have to install them in dual boot, or you have to have two computers. But here it's not the case. You can run two virtual machines, each with its different kind of operating systems or even containers. And the best thing about this is like there's like so many hardware configurations available. Let's just say you have a desktop computer and you have 8 GB of RAM and 1 TB of hard disk and like a lot of other things. So when you want to expand this, you can't do it without actually spending money, of course. You have to buy extra RAM and put it inside the hardware and then like reconfigure the computer and everything like that. What you do here is you simply like delete a virtual machine and then you create a new virtual machine with a updated configuration. For example, you can delete an 8 GB virtual machine and create a 16 GB virtual machine. Simply, you just request more resources. And this configuration can be updated even when the virtual machine is active. For example, like even without deleting the virtual machine, there are ways for you to attach multiple disks. And like let's just say your hard disk is full and you want to add another hard disk. It's simple. You just attach another disk and there's another disk available for you to store more data. So each application is different and there are like so many different applications. For example, video games. Video games are heavy on the CPU. That's what people might think, but a lot of people don't know that video games, let's just say your computer has like 8 cores. A video game uses only 1 core. All the 7 cores are pretty much sleeping when the video game is running because it's not CPU optimized. And so when there are shared cores, each core can actually like, be parallelly running all these things, which is mostly done in servers and business applications. And memory optimized. When you have to access a lot of data from the memory, for example, you're hosting an application or a server which handles a lot of requests, and each request has to be stored in this kind of memory, which is like, slowing down when the requests are made a lot. You need a highly memory optimized. Okay, 1 minute. Sorry about that. Okay, sorry about that. I'm continuing again. So where was I? Memory optimized. Okay, CPU optimized. So when CPU optimized are mostly in productivity. For example, if you're using some kind of program which has to compile a large amount of data, for example, you're a programmer and you have a vast amount of code written and you have to compile. And in that case, you need a CPU optimized system because that is very, very CPU intensive. And if you are somebody who's in blockchain, where blockchain and the computations and all these things are like not really good on when you're doing it on CPUs, then you need GPUs and you need extra. The thing about GCP is that you can actually add a GPU. For example, you create a virtual machine and you can add a GPU to that so easily. And there are some applications which are like using so much of memory and computers, CPUs. CPU applications, mostly the ones which are using most of the CPU are server applications. In that case, you need very high amount of CPU and memory. So there is like so many different ways you can mix and match these things, like 2 GPUs, 2 CPUs, memory optimized, storage optimized, CPU optimized. You can even have storage optimized. Storage optimized is like the way that SSDs are put in instead of traditional hardware disks, because SSDs offer like much more high data write and read speeds, which might be required for some applications. Then again, it comes to at the end, it comes to only the applications which you're using. Okay, so let's talk about working with Google Cloud Platform, Google Compute Engine virtual machine instances. So when you're creating a virtual machine instance, you can do it in multiple ways. So how do you create a virtual machine instance? you can have a boot disk image. So when you're installing a computer and if you know how to install Windows 7, Windows 10, you have a disk image or a disk to install this. So virtual machines, when you create a virtual machine, you can add the appropriate OS in a similar method. You have a boot disk or a boot disk image, you can do that. That is like a typical way of installing any kind of OS into the boot into the virtual machine. And the second option is to use a boot disk snapshot. So what is a snapshot? So when you use an operating system, you come with the default settings and you customize it to a high degree. You may be installing like, the softwares which you use regularly and the kind of hardware you configured it to, like, and the customizations, the options, everything you've done. And you can't keep on using, like, let's just say you migrate to another cloud platform. You can't keep on, like reconfiguring it every single time. That is not really productive. So what you do is you make a boot disk snapshot. So when you actually configure and everything inside the OS or everything like that, you can create a snapshot. So the next time you are installing a virtual machine, you can install the snapshot with all the pre-configured options instead of, doing everything from scratch. Because every time you start a virtual machine, you have a clean kind of installation where you have to do a lot of work, which can be really counterproductive because you have to do it over and over again. So it makes sense to actually go for a snapshot. And you can even do it with a container image. So what is a container? A container is simply a block of code or logic which is independent from each other. And this concept itself goes in like as to whole separate topic where we deploy all these applications and logic using containers, because we can when you're deploying using containers, you can scale rapidly, and it also makes it easier for one program not to be depending on other. For example, if one container like fails, the whole thing doesn't fail. So Docker, Jenkins, and all those people, I mean all those technologies use containers applications. So you can even run container logic inside a virtual machine. So there is a lot of different kind of servers or even operating systems which you can install in GCE. So if you want to install Windows XP or Windows 98 even, you can find images on the internet where you can just download them and install them on the virtual machine and they'll start running. And Windows Server instances. So in GCP, sorry, in Windows Server instances, there's like two options. You can either install with a pre-configured SQL server or you can just install it. Windows servers come with a lot of administrative overhead. And sometimes the SQL server makes it a little bit more because of extra privileges and security and everything like that. So it makes sense to install them separately. And GCP also supports Linux server instances out of the box. And now let's see another way of creating an instance in a GCE virtual machine. Instance using templates. So when you're creating an instance, again, you are having a lot of different configurations. And sometimes you might even have networking capabilities, or you might have installed a lot of software and installed a lot of other kind of things. While this does not have any kind of data to be exact, there is a lot of configuration and softwares to be installed, and you can't keep on doing it over and over again every time you create a new instance. In that case, you save it as a template. So when you save it as a template, you can simply load it back again when you're doing it. And when you're coming to the networking part, so when virtual machine instances are made, obviously once your application starts using the networking code or anything, you will need networking options for your virtual machines. In that case, Google Cloud Platform also supports custom DNS instances. So what is DNS? Domain name server. It's used to uniquely identify a domain, a machine in the server. DNS is like unique. So whenever by default, if you create any kind of virtual machine instance inside GCE, automatically DNS is assigned. But sometimes you want to customize that and have your own DNS, and that is possible as well. And as far as cloud is concerned, people are going to only host applications of large scale in the cloud. Nobody in a large scale company is going to be running only one or two virtual machines. They're going to be running vast amount of virtual machines, which can easily get out of hand. So that's why we have the bulk instance API. So if you want to create like a large amount of instances, and it would be like, tedious and repetitive and redundant to actually like create them each by, manually creating an instance and defining them and everything. So what you can do is you can create them in bulk. You can provide a set of rules and provide the actual parameters which are required, and you can send a request and they'll be created in bulk. So we created a virtual machine instance. So how do we manage it? So if you know anything about managing in any kind of situation, it always depends on privileges. Who gets to do who? If in a classroom environment, the teacher gets to decide who gets to sit in the first bench and who gets to sit in the back bench, what order these things happen. So an administrator or anybody in the cloud administrator or any person who's in charge of managing these things, the main thing he does is privileges, because he grants different users different privileges, how much of the content they can access, what are the functions they access. So there is a lot of ways to do that. The best way to like actually give a person access is a login, which we do it in our typical everyday life. When you have to log in inside our mobile phones, we have a passcode, so the other people cannot access our mobile phones when we don't have access to our phones. And when we enter the computer, we have a password. So that's the same with the cloud. You provide a username and a password, and you get access to the information and the functions which are there in the virtual machine. And the second way is the SSH keys. SSH keys are a bit advanced. So in terms of when you're dealing with sensitive data, like this kind of data cannot be leaked outside, and they are very highly secure, like, confidential. And you want to add and in general, GCP is very, very secure. But, when you have highly confidential data moving around, more people are trying to hack it. So it requires an extra bit of support, extra bit of security. So in that case, you can use SSH keys. And there's also ways of two-factor authentication, which is quite popular these days when you authenticate a process using two different devices or two different ways. So like a person who doesn't have access to both devices or both methods cannot go inside. And the third one is temporary access. Let's just say you have a guest person or a guest developer who's coming here to fix the issues or who's coming here to give you some consulting, and you need to give him some temporary access to the services. In that case, you can give them by temporarily assigning them a username and password, which will be only valid for the duration, or like it'll be a single use. They can't use it more than once. And the best part about GCE is that they have a dedicated VM manager. So what does a VM manager do? VM manager is like a set of tools which helps administrators and architects manage the vast amount of instances. In a project, the amount of instances can go like from 20 to 200 or even more. And in that case, you need somebody or some kind of tools to manage all those things. And that's where VM manager comes in. So what does VM manager help you do? So any kind of virtual machine, you might have installed, like, for example, Windows 10 October update. And October update had a serious security flaw, and which led a few people hack into the OS and something. So by January, they fixed the issue and they release a patch. But your virtual machine is still running on the October patch, and it's vulnerable to the security flaw. So what you have to do? You have to patch it. So for patching it, you need to get the new update and apply it to the appropriate virtual machine. And then inventory. So inventory is simply like any kind of, for example, take a grocery store or a fruit store where they have like a vast amount of apples, oranges, and different kind of fruits, different kind of packages. Each of them are different. For example, apples might get spoiled easily, and oranges might not. All of them are in the same place, but they require different kind of care. And that's the same thing here. Each virtual machine is different with a different configuration, and it's meant for a different purpose. So inventory management allows you to manage all those things depending on what kind of what kind of ways they are useful, or memory optimized or CPU optimized. So you get up, for example, you're applying a patch and it has to be applied only in 3 virtual machines when you have about 20 or 30. So inventory management helps you do that. And configuration management. When you're having vast amount of virtual machines and you have to update a configuration to, for example, the amount of bandwidth you're allotting to each virtual machine is about 20 megabytes. And suddenly you want to update only 3 or 4 virtual machines to have about 40 megabytes of bandwidth. In that case, you can use the VM manager to automatically update only the selected instances based on certain parameters or certain rules, and only update them. And when it comes to advanced virtual machines, the concept of nested virtualization happens. So what is a nested virtualization? So simply, a virtual machine inside of a virtual machine is known as nested virtualization. So when you have a virtual machine and you install another virtual machine inside that, and you install a virtual machine inside that. So why would we do that? Why would we have like a nested virtual machine instead of a virtual machine? It's counterproductive. It's using more resources, because when you're using a virtual machine, the container which is running the virtual machine itself uses hardware. And on top of that, when you increase another virtual machine, you are using more and more hardware. So when this happens, the primary reason for people using nested virtualization is to just ensure data security. Because when you have multiple layers which have to be like across for you to reach a destination, it's harder for people to track like how you went there. So it provides an extra layer or like multiple layers of security based on how much you're nesting it inside. And one of the biggest things about GCP is their GPU support. And if people might have not heard, the reason they added GPU support was for Google Stadia, because gaming has become like a huge deal now. And Stadia was one of the biggest experiments Google made, where they used a vast amount of GPUs to host something called cloud gaming, where users do not have to upgrade their PCs and to have advanced hardware configurations. And while the project failed, and GPUs are the cheapest in terms of Google, you can easily add a cheap GPU option to your compute engine. So what does it give? Blockchain. It's also useful in business and machine learning applications, and TensorFlow or any kind of library, PyTorch or any kind of machine learning library you're using are much efficient if you run them on the GPU. So even though their grand cloud gaming technology failed, it can be still used for machine learning, image processing, and computer vision, which are like more complicated. For example, computer vision is like an upcoming field where the computers get to see and detect objects, and they can even track. So all these applications, you need a lot of GPUs, and it's really easy to scale based on GPUs. You can even use 10 or 20 GPUs without much reconfiguration, compared to the CPUs and memories, which you have to reconfigure each and every time. And networking. So when you have like about 200 virtual machines, and let's just say you have virtual machine 1 to 200, and you have some data which is on virtual machine 2, and it has to be accessed on virtual machine 150. So how do you transfer data from one virtual machine to another? For example, you put a file in here, but the file was supposed to be in 150, but it's in 2. So that's where virtual private cloud comes in. So since virtual machines are literally virtual machines, which are like virtual computers running on the cloud, so you essentially having 200 computers. So what's the point of having 200 computers if you can't connect them to each other? If you see in our labs and any kind of computer centers or something, there is a network which connects all the computers together. So that's the same thing here. Virtual private cloud enables each and every virtual machine to be interconnected and create a local network or even a wide area network or even connect to the internet. So like one virtual machine connected to the internet and all the other virtual machines connected to that virtual machine, which enables like all your applications to be going to the internet, which is ultimately where we are going. So that is done through the virtual private cloud. And that marks the end of our session. If you have any kind of questions regarding the session, Google Cloud Platform, or even the other services which I mentioned, you can ask me now. And while you're doing that, please fill in the evaluation forms. Your feedback is very valuable to us. You can click on the link and you can submit your evaluation, how the session was it useful, was it not? Any questions?
Excuse me, sir.
Yes.
You just mentioned about GPU. Can you elaborate it? What exactly it is?
GPU is, I'm sorry for not elaborating on that. Once again. I'm sorry for not elaborating on that. GPU is like a graphics processing unit. It's a customized hardware meant to be processing graphics. So while its primary audience is the games, it's moved on to much more application oriented. So when you have a CPU, you're processing all the data using mathematical calculations. So the CPU is very, very good in calculating mathematically floating point operations or any kind of general mathematical operations, which are generally like there in computing all the time. But GPUs are specialized. They are like, better at drawing images using mathematical coordinates and calculating image-based data. So when you're using computer vision or when you're sorting out images on the internet, then GPU is a better option to do it. Graphics processing unit.
So basically, what it means, it is a graphics card which we used for gaming generally, right?
Exactly. So they have the servers. They have like a large stack of graphics cards, and like you can get access to that. You can actually, like, for example, if you have enough technical knowledge, you can actually run your games on Google Cloud Platform. For example, let's just say you don't have like you're getting GTA 5 and you're not able to run it on your computer because you don't have this thing. So instead, what you can do, like buying an expensive system, you can go create a virtual machine, add 10 GPUs to it, and you can run it very, very smooth, just streaming the output to your computer.
Okay, sir. Thank you.
Okay, I'm taking a question from Deepak Patel. How to switch to GCP profile from Oracle DBA. So when you're coming from Oracle DBA, you are essentially a database administrator, which makes it, they have something called BigQuery, which is a common thing for Oracle and SQL and everything. So when you have a database background, it should be really, really easy to migrate for you to like GCP. They have a lot of migration options, and GCP almost supports each and every SQL from MySQL to SQL Server to Oracle database. So you will find your place here easily. If you want like more specific information, like I can I can get you a link on where you can study more about making a switch from Oracle DBA to full-time being a DBA on the cloud.
Yeah, thank you.
And any more questions?
So just one last question.
Yes, ask any amount of question.
See, it is not like that GCP is the only cloud option out there, right? There are many
Okay.
cloud providers. So how is GCP better than all of that? Means like there is AWS, there is Microsoft Azure, there are many more such. I won't mention anyone, but how is GCP better than any of them, and why GCP basically?
GCP is offers a lot of pricing options. Any kind of, when you're choosing any kind of Google Cloud, I mean, any kind of cloud platform, you have to consider a lot of different things, like what kind of application you're doing. And if you see all the Google APIs, if let's just say your application is using a lot of Google technologies, then if you, for example, these Google people are like very well versed in video processing and search engines and global operations in that kind of things. So when you go for Google platform, you get the same services they are using for their large scale products. And GCP is right now the best cost option compared to AWS and Azure. And if you're coming from a open source perspective, GCP is a better option compared to Azure. Although like Microsoft is like, betting big on open source these days, they are still a monopoly. Like they have like they make it sure only like their platform gets access to most of what they do. They have all the services, like each and every service you can actually, if you're going for a big thing which requires a lot of resources, a lot of features, a lot of options, then there is no other, like there's not a question. You have to go for AWS. But when you're going for a project which is mid-scale or like very specific to Google platforms, for example, Android, if your platform is just Android, not anything else, then it makes natural sense for go to Google platform.
Okay, sir. The reason I asked you this is, see, I am a student and I am just about to enter all this corporate world, and everywhere I see around is everywhere it is like only AWS and Azure, which is why I thought, and Google Cloud was something new to me. So I thought, how is all this better than this, and how can I find my scope through this?
If you are like, trying to get into some kind of technology, the main thing you have to do is research if there is like more scope of, like if you can go to platforms such as LinkedIn or any kind of data, you can find the jobs which are listed, so you can just easily get an idea of what kind of job openings are there. And if you notice, most of the times job openings for AWS and GCP, because a lot of enterprises over US, they use Azure only if they are oriented with the .NET. Other than that, most people are like adopting AWS. And it all depends. Like if you're a student, if you want to get into one of those technologies, the main thing you want to look for is like jobs. If there is scope for the technology you're reading, I mean, you're getting into.
Exactly, sir.
And DNS, domain name system, like a DNS server is like for example, when there is like about 100 systems in your network, and DNS is used to uniquely identify each one of them in that. Like if you have there is like two kind of things, like static IP and dynamic IP, right? So when you have a internet service provider, like they have static IPs only if they are hosting something like servers or something. And if they're just accessing the internet, then they use dynamic IP because they don't want to waste some number of that static IP.
Okay.
That's the same thing with DNS. Like each and every system that enters the network is assigned some kind of ID, because like, for example, when you're in a classroom, each and every student is given a number, student number 1, student number 2. It's something similar to that.
Got it.
And
Thank you.
can we get useful links for GCP study material? GCP study material, you can get started using online tutorials. Google Cloud has a lot of, there is this channel called Google Developers. In YouTube, there's a lot of videos. There's a lot of people doing GCP training. And you can even get free books online for GCP.
Hi, this is Swapnil here. My question is, what GCP has for e-commerce based websites or applications? So you know that AWS provide more services, and they are into almost all the technologies that are required for anything.
If you are
So,
using, let's just say you're using e-commerce, that is
yes.
the easiest way to get into e-commerce is like WordPress and WooCommerce. So GCP, for GCP, as far as it's concerned, like you can pretty much run anything. So let's just say you have a WordPress installation on that, and you can easily add on top of that. That would be the easiest thing to do. Let's just say you're building your own custom solution. You're using React or AWS, Angular, React or Angular or any kind of front-end framework. Then you can use the GCP as a backend, the kind of storage and analytical services and machine learning. You can implement all of them on the GCP.
I don't know if it is a Java-based applications.
Yeah, Java is allowed. Like you can, as far as any language, anything is allowed here. Even C#. Like if you come from there is some kind of a managed layer above all these things, which makes every single platform, every single language, you can access it. In SDKs, you can access.
Right. But my question is, what will be the benefit that I'll be getting by choosing GCP over AWS?
Like let's just say that you are having a simple application like, for example, you are just running some e-commerce which is not that big. If, for example, Flipkart or Amazon, they sell everything, and in that case the daily traffic will be like a lot, and your customers will be like vast, and each of them will have different expectations, and you need different kind of services to keep them together. In that case, you need to go for AWS for sure, because they have a lot of services. But let's just say your e-commerce thing is very niche. For example, just fashion, like Myntra.com. They just deal in fashion. They're not dealing with anything. But if you take Amazon, they have everything. But Myntra is only clothes. They don't go beyond anything in clothes. So in that case, GCP would be a good option because it's very targeted and you will be getting cheaper. AWS, I guess, expensive. Like all these platforms, the monthly bills will scare people if they don't do the cost optimizations properly. There are a lot of people involved in this cloud technologies. They are in charge just of the costing, because since this technology is scalable, the bills could easily go to the roof for even the smallest like scale or something. For example, there was a campaign run in Brazil which collected over 30 to 1 crore, 30 lakhs to 1 crore. They run it through the cloud. But since a large amount of people accessed the cloud platform on a like same day basis, the cloud bill itself came for 1 crore. So their fundraising was like wasted because they didn't optimize it properly. When you have
So the resources were not properly managed, right?
yeah, exactly. So when you
Cloud
have,
resources were not properly managed.
yeah, like if you are going, it will be very expensive. And if you are targeting, if you wanting something like that very expensive, you need a lot of customers as well. So if your audience is just clothing, or if you're just having a bookstore, then GCP is good because the price is lower and the amount of technologies you require is lower as well. So it will be very beneficial for you to use GCP. But if you're targeting something on a global scale, anytime you're targeting something on a big, grand global scale, AWS is a clear winner. But other than that, targeted markets, targeted zones, and customer bases, GCP and Azure can score as well.
Yeah,
Okay.
thanks. That was beneficial.
Okay.
So
Any
I
more
have a
questions?
question.
Oh
I
yeah,
have a
tell me.
question reading the app engine and compute engine. So what is the
Okay.
exact difference? Both are
Compute engine simply gives you, like, you can build your own computer. So if you're like building your own computer, you choose the RAM, every kind of thing you want, right? So compute engine simply gives you that thing. You launch a virtual machine and you can build your own computer using that, using the configuration you want. So if you want a specific kind, like let's just say you know that your application is going to require 16 GB of RAM and it requires 2 GPUs and 4 CPUs roughly. So you can build your own computer using the compute engine. But the app engine is a pre-configured platform. For example, Windows or Linux or any kind of pre-configured platform. So if you are having a compute engine, you can bring in your own disks as well. For example, let's just say you have Windows 98 programs. So inside this like that, you can bring it like that. Or if you are having your own operating system, or if you're having your own kind of customized operating system, let's just say you have a company where you customized a Linux platform to your level. I mean, to suit your company is better, because Linux is an open distribution. All the companies, they customize it heavily. So in that case, compute engine is an option. But like app engine is simply like you bring an app and you run it. If it's a Windows app, you run it in Windows. If you have a Linux app, you run it in Linux. It's like that. And Macintosh is not available because Macintosh is not an open platform.
Okay. Thank you. Got it.
Any more questions? Okay, then that concludes our session. Thank you for all coming, and please fill in the evaluation forms in the link. And thank you.
Thank you so much.
Thank you, Kumar.
Thank you.
Thank you so much. Yeah.
Thank you.
Bye.